The Pythagorean theorem can be used with any right triangle to identify missing sides or to determine whether three values can be a right triangle. So the Pythagorean theorem we learned was a squared plus b squared equaled c squared. So the sum of the squares of the lengths of the legs is equal to the square of the hypotenuse. So when you have a right triangle, A and B are the lengths of your legs, C is the hypotenuse. It's always the longest side, and it's always across from the right angle. So we can use this information to find missing sides. So if I have two measurements for A and B, a measurement for A and B, I can use the theorem to figure out what the measurement is for C. And if I am given C and A, I can use that information to figure out a measurement of B. I can also tell whether the triangle with the given sides is a right triangle by using the theorem. All I need to do is, say we use the 10, 6, and 8. C is always the longest side. The hypotenuse is always going to be your longest side. So whatever is your greatest value has to be the hypotenuse. So for this one, I can put my values. So 6 squared plus 8 squared equals 10 squared. I can see if it is true. So 6 squared is 36 plus 8 squared is 64 equals 100. And yes, 36 and 64 do equal 100. So this is a right triangle. This can be the measurements of the sides of a right triangle. If we look at another one, when we look at number 3, I'm going to skip over here, 18 has to be the hypotenuse. So you have 15 squared plus 10 squared equals 18 squared. Well, 15 squared is 225. 10 squared is 100. And 18 squared is 324. Oops. 324, there it is. 225 plus 100 gives me 325 equals 324, and that is not correct. Therefore, this one, the sides of a right triangle cannot be 15, 10, and 18. Another one you want to look at is number 5, one like number 5. When you have the roots. So you have the square root of 3, the square root of 4, and the square root of 5. The square root of 5 is the greatest value, so that has to be your hypotenuse. So you're going to look, is root 3 plus root 4 equal to root 5, the square of these. Okay, so the square of a root gives me itself. So if I take square root of 3 times square root of 3, I get the square root of 9, which is 3. Square root of 4 times square root of 4 is the square root of 16, which is 4. Square root of 5 times square root of 5 is the square root of 25, which is 5. And no, 3 plus 4 plus 5 is not a right triangle, so therefore these cannot be your measurements for a right triangle. You could do the same thing with the other 3. We can use the Pythagorean theorem to figure out the distance between any 2 points on a coordinate plane. When you have a d is equal to your distance between the 2 points of x sub 1, y sub 1, so this point here, x sub 2, y sub 2, okay, x sub 2, y sub 2 is here. And then you can find the distance between these 2 points. So, I don't know what I was doing. So, this is exactly like our Pythagorean theorem. So if we take a look at this distance here, we can go from this point to this point. We look at it, it's almost like your slope, and we say, all right, well, if this is a squared plus b squared equals c squared, you take the square root of a squared plus b squared, and it's going to equal the square root of c squared, which is going to give us that distance. Okay, we can just replace it with d instead. So finding your distance between any 2 points, we're going to use this formula right here. So the distance equals the square root of x sub 2 minus x sub 1. So x sub 2, we're going to call it 2, minus x sub 1, which is negative 3. Okay, that quantity squared plus y sub 2, which is negative 1, minus y sub 1, which is 5, that quantity squared. So the distance between these 2 points on a coordinate plane, we can use this formula. So d is going to equal square square root of, so 2 minus negative 3 is 5 squared, plus negative 1 minus 5 is negative 6 squared. So the distance is going to equal the square root of 5 squared is 25, plus negative 6 squared is 36. And then you have 25 plus 36. So the distance equals the square root of 61. And that can't be simplified. So the distance between those 2 points is the square root of 61. So looking at this next one, you have 0, 4, and 5, 2. We're going to use that formula. So distance equals the square root of x sub 2 minus x sub 1. So 5 minus 0, quantity squared, plus 2 minus 4, quantity squared. So the distance equals the square root of 5 minus 0 squared is 5 squared, plus 2 minus 4 is negative 2 squared. So distance is going to equal 25 plus 4. The distance is going to equal the square root of 29, and that can't be simplified either. Pause the video for just a moment, and I want you to do number 9 and number 10. The answer for number 9, D, will equal the square root of 146. And the answer for number 10, you're going to get D equals the square root of 320, which can be simplified into 8 root 5. So in this last piece, you can use this distance formula. It says on a coordinate plane, a triangle has vertices at the points. So 20, 10, 60, 50, and 80, negative 30. Is it a right triangle? So here, if you're looking at a coordinate plane, okay, over 20 up 10 is about here. So over 20 up 10, say it's roughly here. Over 60, and then up 50, so over 20, 60, up 50, we're just going to call it here-ish. And then 80, negative 30 is going to give you down here or so. So here's your right triangle, if you're looking at it. Well, what could potentially be your right triangle? So if I call this point 1, point 2, and point 3, if I find, so this one is point 1, point 2, point 3, if I find the distance between each one of these points, like I did up top, and then I plug that into my Pythagorean theorem, I can see, is this actually a right triangle? So pause the video, find the distance between point 1 and 2. So point 1, you have 60, 50. Point 2, you have 20, 10. Okay, so you're going to do distance equals square root of x sub 2 minus x sub 1 squared plus y sub 2, 50, minus y sub 1, 10. Woo, squared. Okay, you're going to find this distance here. You're going to find this distance between 2 and 3. So 3 is 80, negative 30. And you're going to find this distance here between 3 and 1. And then when you get those 3 values, put them into the theorem itself. Okay, and then you'll solve and you'll see, is it a right triangle or not? So take a moment and do that. You'll find out the distance between 1 and 2 is going to be, so from here to here, you're going to get the square root of 320, or 3,200. So the distance between 1 and 2. The distance between 2 and 3 is the square root of 5,200. And then the distance between 3 and 1 is the square root of 6,800. I'm not simplifying these. I don't need to, because I'm going to put them into my theorem. So this has to be, that's the largest, so it has to be the hypotenuse. So if I take the square root of 3,200 squared, so a squared plus b squared, so 5,200, equals c squared, so 6,800 squared. Add those two values. The square root of that squared is going to give me the 3,200 plus 5,200 equals 6,800. This is some sloppy writing. Equals 6,800. 3,200 plus 5,200 is 8,400. That does not equal 6,800. Therefore, this is not a right triangle. Okay. So using your coordinate plane, you can figure out, and using that distance formula, whether these possibly form a right triangle or not.